Hello students, today we are going to discuss very important topic, and the name of the topic is Nernst equation. This is very important, and I think 100% you will get one question from this topic in 2021. Okay, so if you have any doubt, then write in the comment box, then I will try to solve. Okay, so before understanding the Nernst equation, a very short topic, that is Gibbs free energy. We will understand Gibbs free energy. So students, already in thermodynamics, that is in class 11th, we have studied about Gibbs free energy, the energy which is required to do some useful work. Okay, already we have studied, and symbol of Gibbs free energy is delta G naught. Okay, change in Gibbs free energy, because exact amount of Gibbs free energy we cannot determine, so generally we deal with the change. Okay, so student, suppose how we will calculate the Gibbs free energy. Suppose we are using a electrochemical cell in a standard condition, and what is that standard condition? Both solution will have same concentration, and this cell we will keep at 25 degrees Celsius. Okay, so what is the concentration of zinc sulfate? 1 molar, and here silver rod is dipped in silver sulfate, so concentration of silver sulfate is 1 molar. ठीक है ना? Okay, so student, we know that at left hand side oxidation occurs and right hand side reduction occurs. We have studied in the previous 3 videos. Okay, so how we will calculate the EMF of the cell? We will calculate EMF of this cell, that is E naught cell. Naught means standard, because both electrolyte have same concentration and the temperature of this setup is 25 degrees Celsius. So these conditions represent the standard condition. So EMF of the cell, potential difference, this is the EMF is the electromotive force, and we will calculate by taking the difference of which? Reduction potential of cathode minus reduction potential of anode. We will use reduction potential only. Generally we know that oxidation occurs at anode, but here we will take same term, that is reduction potential. Reduction potential of cathode minus reduction potential of anode. Reduction potential of cathode minus reduction potential of anode. And these two values examiner will provide you. Okay, so you will just, for example, if I am saying reduction potential of silver is 0.80 volt and reduction potential of zinc is minus 0.76 volt, what will be the value of this cell? What will be the value of EMF of this cell? So what is the value? 0.80 minus what is the value of E naught A, that is anode, minus 0.76 volt. And one more thing, student, if you are not able to check which metal will act as cathode, for example, as I am saying silver is acting as cathode and zinc is acting as anode, if you are not able to distinguish which metal will act as cathode and anode, just subtract the lower value from higher value, mean take the difference higher minus lower value, as I am doing here. 0.80 minus 0.70, higher value, the metal which has higher value definitely will act as cathode. Okay, this is trick. Metal which has higher value of reduction potential, it will act as cathode. Okay, you will place that metal at right hand side. So answer is 1.56. 1.56 volt will be the potential difference. Okay, so this is standard condition. But here we are going to calculate Gibbs free energy. So what will be the answer? Minus NF, and we have calculated E naught cell using this formula, E naught cell. So value of E naught cell is 1.56 volt. So next part is what will be minus N, minus this sign. What will be N and what will be F? So student, I am telling you about F. F is the Faraday constant. F is Faraday constant. Faraday constant. Okay, and if it is constant, mean its value will always be constant, and its value is 96,500 coulomb. 96,500 coulomb. Coulomb mean it is the value of charge. So what is Faraday constant? One time CBSE board has asked this question, as well as ISC also. Okay, I think 2016 or 17. What is the value of 1 Faraday and what is 1 Faraday? So student, 1 Faraday is the charge. Charge of which? It is the charge of electron, but not of one electron. It is the charge of 6.022 into 10 raised to power 23 electron. Okay, इतने इलेक्ट्रॉन का चार्ज 1 Faraday होता है. And we know that value of charge on one electron is 1.6 into 10 raised to power minus 19 coulomb. When you will multiply these two values, then you will get 96,500. It is clear or not? So student, this is very very important. What is 1 Faraday? 96,500. And what is the definition of Faraday? It is the charge of 1 mole of electron, and the number of electron in 1 mole, it is 6.022 into 10 raised to power 23. So student, we have calculated Faraday also, that is 96,500. Okay, so now next part is left, and next part is what is the value of n. This is very important. सारा game is n का है इस Nernst equation में. Okay, so how we will calculate the value of n? Just check. Student, I told you that at anode oxidation will occur. At anode oxidation will occur. So to calculate the n, you have to write the cell reaction. Otherwise, you can't do this topic. What you will do? You will just calculate the value of n, and to calculate the value of n, you have to write the cell reaction. So I am writing the cell reaction. I am rubbing this and just calculate the value of cell reaction. So how we will represent the cell reaction? This is very easy. Just place a sign of arrow. Okay, so we will write reactant and product. So here what is happening at anode? Oxidation is occurring. Oxidation means zinc ion will lose its electron. Here what happens? Oxidation. And at right hand side, reduction. You will keep in mind always. Here oxidation will occur, here reduction will occur. But don't get confused. To calculate the EMI, we take reduction potential of right hand side as well as reduction potential of left hand side. Okay, we use same term, that is reduction potential. But actually oxidation occurs at left hand side, that is at anode. Okay, so what will happen? Here zinc will lose its electron, that is zinc 2 positive. Okay, zinc has lost its electron and converting zinc solid into zinc 2 positive. Okay, one thing. Second, and what is happening to the left hand side? This arrow is representing the reactant product, not left hand and right hand side. Okay, I am just writing the reaction. And what is happening at right hand side? Silver positive will gain the electron and will be deposited at the cathode. Already we have discussed. So what will happen? Silver positive will gain the electron and it will be deposited at the anode. So Ag positive will be changed into Ag. Okay, if you are not getting what I am saying, so just watch second video where I have told you to represent the cell reaction and cell representation. Okay, so now what is next? You will equate the charge. You will equate the charge. How many unit positive charge is there? 2 unit positive charge. Here only 1 unit positive charge. So you will multiply this by 2. Okay, now charge has equated. 2 unit positive charge on left hand side and 2 unit positive charge on right hand side. If 2 atom of silver you have taken, so you will take 2 also. This is cell. Now equal charge right hand side and left hand side is n. n क्या है? ये देखो चार्ज हो गया. जिंक ने कितने इलेक्ट्रॉन लूज किए? 2 इलेक्ट्रॉन लूज किए. ये सिल्वर ने कितने इलेक्ट्रॉन गेन किए? 1 silver has deficiency of 1 electron, so 2 silver ion will have the deficiency of 2 electron. So this is the deficiency or number of electron lost by an atom. What is n? Number of electron participating in the reaction. How many electrons are being released by the zinc? 2 ion, and these 2 electrons are being accepted by the silver ion. So here the value of n is 2. Again I am telling you student, just check the maximum charge. It is n. This is strict. Just check the maximum charge. How many maximum charge here? 2 unit. Here 1 unit. Just take maximum charge 2 unit. So it will be the value of n. So minus 2 into 96,500 into 1.56, and answer will be in the joule. Answer will be in the joule. This is Gibbs free energy. I think आपको calculate करने आ गई होगी. You will calculate the number of electron participating in the reaction. Faraday constant will be always constant for each type of reaction, that is 96,500, and E naught cell will be, you will calculate cathode minus anode. Using cathode minus anode, that is higher value minus lower value, you will calculate the E naught cell. Okay, so next topic we will discuss Nernst equation. Take the screenshot of this topic. Okay students, so now we will discuss Nernst equation. Again I am representing the cell. Zinc is dipped in zinc sulfate, but the concentration now C1. Okay, any concentration. And silver is dipped in silver sulfate and concentration is C2. So student, make it clear, here there is a difference in concentration cell. So now this type of cell is not electrode cell, this is concentration cell, because there is a difference in the concentration. Okay, even here I can use zinc in zinc sulfate, but concentration will be different. Okay, you can take same electrode, but concentration of that electrode should be different. Okay, so question is that what will be the value of electromotive force of this cell? So we will not calculate reduction potential of cathode minus reduction potential of anode. Simply it is not possible. Answer will be wrong. Okay, so we will use some different method, because now concentration is not 1 molar. Okay, if concentration is 1 molar, then we are calculating cathode minus anode. But here concentration is different and not 1 molar, so we will use some different method, and the method suggested by Nernst. So equation is known as Nernst equation. Okay, so here I am writing the reaction, cell representation and then cell reaction. So student, in the class 11th you have studied this reaction in thermodynamic. Gibbs free energy, this G delta G is not in standard condition. It is equal to the Gibbs free energy in standard condition, or it is constant, already you know. Okay, and its value is 8.314 joule per mole per Kelvin, etc. T temperature, it will be in Kelvin. Ln is what? This is log 10, 2.303 log 10. Okay, so this is natural log. Okay, and it is equal to 2.303 log 10. And product upon reactant. And what will be the product in this reaction? And reactant left hand side. Okay, but in equilibrium I told you, you will take the concentration of solid and liquid 1. बताया था ना ये मैंने आपको. So here you will take the concentration of solid 1. And what is solid? Zinc rod is solid. So here you will not use in this, when you will write this value in equation. Okay, so I will tell you later. Just understand the equation. What will be the equation? This is not Nernst equation. Now I am drawing the Nernst equation. So student, right now I told you delta G is equal to what? Minus NFE. Okay, but if I will not use the standard condition, then I will write NFE cell. NFE cell. It will be equal to minus NFE naught cell. If I will use standard Gibbs free energy, then I will use standard cell, EMF cell. And if I will use normal Gibbs free energy, then I will use simple normal electromotive force. Okay, and plus RT Ln, concentration of product over concentration of reactant. It is clear? So here student, I am dividing this equation by minus NF. Minus NF E cell divided by minus NF is equal to minus NF E naught cell. It will be divided by minus NF plus RT upon minus NF. This term will also be divided by minus NF. Okay, Ln product upon reactant. Okay, so it will be cancelled. E cell ये आ गया, देखो ये निकालना है हमने. अब ये स्टैंडर्ड कंडीशन का नहीं है. दिस इज नोन एज ई सेल. दिस इज व्हाट? ई सेल. यही हमने निकालना है ना. तो ये देखो किसके इक्वल आ रहा है. दिस इज इक्वल टू द माइनस ई नोट सेल. E naught cell. Here plus minus will be minus. Okay, RT upon NF. Ln, I can put the value of Ln what? 2.303 log product upon reactant. Okay, you may get some noise. Okay, so product upon reactant. So student, here it is the value of electromotive force when cell is not in standard condition, mean it has the difference in concentration at both electrodes. So E cell will be equal to E naught cell. What? How will you calculate E naught cell? Cathode minus anode. Simply as we are calculating earlier. E cathode minus E anode. So value of E cell is equal to E naught cell minus R is R. What I told you, 0.0821. Okay, and T R 8.314. T 298 Kelvin standard condition. F 96,500 इफ आई विल पुट दिस वैल्यू एंड 2.303, ये सब मैं अब देखो आपको ये बता रहा हूं, इन प्लेस ऑफ दिस व्हाट कैन आई राइट, 0.0591 अपॉन n log concentration of product upon concentration of reactant. Okay, this is Nernst equation student, this is Nernst equation, very very important. बट अभी इसको यूज करना सीख लीजिए आप, कैसे होगी ये बहुत इंपॉर्टेंट है। ये समझ में आ गया, आर की वैल्यू मैंने, टी की वैल्यू, एफ की वैल्यू रख दी है, पुट कर दी है मैंने, ठीक है। और ये जो स्टैंडर्ड कंडीशन का इनोड सेल होता है, इसमें से माइनस कर देंगे तो हमारे पास जो स्टैंडर्ड कंडीशन नहीं है, उस कंडीशन में सेल का ईएमएफ निकल कर आ जाता है, ठीक है। अब जैसे मेरे पास ये रिएक्शन है, मैं इसको रिप्रेजेंट कर रहा हूं, देखो व्हाट विल बी द आंसर, ई सेल इज इक्वल टू ई नॉट सेल माइनस 0.0591 upon. Student, what will be the value of n? What I told you, n is the number of electron participating in the reaction. So directly ये क्या होता है, किसके इक्वल होता है, मैक्सिमम चार्ज के। Here one silver has 1 unit positive charge, so 2 silver will have 2 unit positive charge. यानी कि सिल्वर जो है वो 2 इलेक्ट्रॉन गेन कर रहा है, ठीक है। तो n will be 2, या आप यहां से देख सकते हो जिंक न्यूट्रल है, यहाँ जिंक 2 पॉजिटिव हो गया, इसका मतलब जिंक जो है वो 2 इलेक्ट्रॉन लूज कर रहा है, ठीक है ना, लो। नाउ प्रोडक्ट, ओके, सो स्टूडेंट प्रोडक्ट इज दिस वन, ये प्रोडक्ट है आपका। बट व्हाट आई टोल्ड यू, द मेटल विच इज इन सॉलिड स्टेट वी विल टेक इट्स कंसेंट्रेशन यूनिटी, 1 लेंगे हम। तो अब सॉलिड स्टेट में कौन है, देखो सिल्वर, सिल्वर तो रोड है ना, तो रोड तो सॉलिड होगी, तो हमने ये नहीं लेना, दिस इज वेरी वेरी इंपॉर्टेंट, मीन यू विल टेक ओनली दोज मेटल आयन विच हैव पॉजिटिव चार्ज। जो पॉजिटिव चार्ज है, नेगेटिव चार्ज है, मीन वही सॉल्यूशन के अंदर होगा, पॉजिटिव नेगेटिव वाला ही होगा, न्यूट्रल पे तो वो सॉलिड फॉर्म में होगा, उसको आपने नहीं लेना। यू विल टेक ओनली पॉजिटिव एंड नेगेटिव चार्ज। सो वी विल टेक हियर व्हाट इज प्रोडक्ट, प्रोडक्ट इज जिंक 2 पॉजिटिव, प्रोडक्ट इज जिंक 2 पॉजिटिव अपॉन, नाउ कम टू द रिएक्टेंट, रिएक्टेंट इज व्हाट, जिंक एंड Ag पॉजिटिव। अगेन वी विल नॉट टेक जिंक, क्योंकि जिंक तो रोड है, आप जिंक छोड़ दो, आप कौन लेंगे, हम सिल्वर। अब इसका टर्निंग पॉइंट मैं बता रहा हूं, ये आपने सिल्वर लिख दिया, सिल्वर पे कितना यूनिट चार्ज है स्टूडेंट, 1 यूनिट पॉजिटिव चार्ज है, लेकिन वेरी वेरी इंपॉर्टेंट, मोस्ट ऑफ द स्टूडेंट्स skip this step and get 0 marks. Okay, after doing everything they skip this step. What, how many atom of silver is there, 2, so this will be the power, it will be the power. ये आपने ध्यान रखना है, this is very very important, that's why you need to balance the equation. If you will not balance, then you can't get this number and marks will be 0. It is clear? So what is the zinc, its concentration, and what is the concentration of zinc positive, C1, and it will be given in the numerical. Tomorrow we will do some question. ये आपको वैल्यू दी हुई होगी जिंक सल्फेट की, वो यहाँ पुट कर देंगे, सिल्वर सल्फेट की आपको कुछ वैल्यू दी हुई होगी कंसंट्रेशन, वो यहाँ पुट कर देंगे और उसकी पावर 2 बना देंगे। और आपका देखो ये कैसे निकलेगा, ये अभी आपको मैंने बताया 0.80 माइनस 0.76, ये आप कैसे निकालोगे, ई कैथोड माइनस ई एनोड से। दिस इज व्हाट, दिस इज कैथोड एंड दिस इज व्हाट, दिस इज एनोड। You will take the difference. Already we have calculated in the previous question. It was 1.56. So 1.56 minus this value. I think आपको ये चीज समझ में आ गई होगी. Tomorrow we will discuss numerical. Student, without learning this equation you can't do any question. So watch this video again and again, and tomorrow we will discuss some numerical which are based on this equation. तब तक के लिए गुड बाय, और इस वीडियो को देखिए, स्क्रीनशॉट ले लो फटाफट.